Hello scholars, it's Mrs. Del Rosario again, here with your second video for the week. So we're on the distance learning week 5, and we've been really focusing on patterns in math and thinking how can patterns help me solve math problems. So today we're going to kind of push our thinking a little bit. On Monday we started talking about what is a pattern, and we defined it as a pattern is a series or sequence that repeats. Well, today I want to push that thinking, and we're going to kind of narrow it down to math patterns. So math patterns are sequences that repeat based on a rule, and a rule is a set way to calculate or solve a problem. So where can we see patterns? Well, we probably saw patterns in different pictures, kind of like the one that was just posted on the last slide with chevron, which is one of my favorite patterns in my classroom everywhere. But patterns are more than just pictures or just images we can see. Patterns will happen in numbers too. One example is when we skip count. Whenever we skip count, that's a pattern. If I start at 0 and I'm counting by 5s, I know what's going to come next in the pattern because my rule is plus 5 each time. So 0, 5, 10, 15, 20. Or in this example, if I start at 0 and my rule is to count by 2s, I know that it's going to go to 2, then 4, then 6, then 8. And I can see a picture of that here, right? I have 2 blocks, 4 blocks, 6 blocks. I can see it's growing by 2 each time. So that the next in my pattern will be 8, then 10, then 12. If this picture continued, what would come next? Shout out your answer right now. That's right, 14 would be next. How did you know that? It wasn't in this picture. You knew it because you continued the pattern. 14, 16, 18. So we're counting by 2s. Patterns also occur in nature. Look at all these beautiful spirals you see. So if we look at the hurricane, it's kind of spiraling out this way. We have a spiral here on this shell. This rose kind of, oh, I think I drew that backwards, but it's spiraling out. This shell, you can see the spiral going. So just for your information, there's a really cool phenomenon or sequence of numbers, a pattern, called the Fibonacci sequence. And the Fibonacci sequence is a series of numbers so that if you have 0 and 1, when you add the first two numbers, you get the next number in the pattern. So 0 plus 1 gives me 1. 1 plus 1 gives me 2. 2 plus 1 gives me 3, the next number in my pattern. 2 plus 3 gives me 5. So to find the next number in this sequence or this pattern, you're going to always add the two numbers before it together. Well, these numbers, when we make square numbers, so when we go 1 times 1 is 2, 2 times 2 is 4, when we square the numbers, we end up getting a nice spiral. So we can see inside the spiral, where did my pointer go? It says 1 and 1, and then it's 2, then 3, then 5, and 6. And the interesting thing is, this spiral is found out through nature all the time, which I think is pretty cool. Nobody's saying, hey, Mr. Lizard down here, you need to grow your tail so it makes this Fibonacci sequence, the spiral, happen. It just does. It's a naturally occurring thing. So one of your math challenges this week can be to explore more about the Fibonacci numbers and why that works out. But I just wanted to show you an interesting pattern that we see in nature often. So are patterns important? Why are we spending all week talking about patterns, Mrs. Del Rosario? Well, scholars, great question. We talked about on Monday how math practices are things all mathematicians, that's us, we do math, do or should do when they're solving problems. So we looked at this math practice 8 and it said we're going to look for and express regularity in repeated reasoning, or we're going to see the pattern or connection. So if I'm looking at this particular picture, I know that the next shape I'm going to see is a square because I can use the pattern to help me figure that out. But guess what, scholars? Patterns are not just part of one math practice. They are in fact part of two. So practice number 7 is look for and make use of structure. Again, see the pattern or connection. So this would be like when we were doing our skip counting by 2s. I could see the pattern. Each time I'm going up by 2. If I'm skip counting by 10s, I see a pattern. Each time I'm going to go up by 10. This works when I'm doing multiples of 10 too, right? If I have 22, and then my next number is 32, and the number after that is 42. Scholars, what do you think is going to come next? Shout out your answer. That's right, the next number would be 52 because I'm only going up by tens each time. So I know the tens in a two-digit number are the first digit, and that's the one I'm going to change. I know when I'm counting by tens, I don't need to change the number in the one spot. I'm using that pattern or structure to help me solve the problems. So here's some more. We have 200, 210, 220, 230. What comes next? That's right, 240 because I am counting by tens. Here I have 100, 105, 110, 115. What will come next? Yes, it's going to be 120 because I'm counting by fives. Here we go. 80, 84, 88, 92. Well, I'm not counting by twos because it's not 80, 82, 84. So to go from 80 to 84, I go up 4. To get from 84 to 88, I need to go up 4. To go from 88 to 92, how many do I go up? That's right. On the bottom, I'm skip counting by 4. So 92, and then I would need to go up 4 more. That would give me 96 for my next number. Here I pulled some problems from Engage New York, or the Eureka Math that we do in school, from one of the sprints. And we've often had talks in class about how can patterns help us. So let's look for a pattern here. So pause the video and look at these problems. Is there a pattern you see that's common to all the problems? Pause the video now. All right, thank you for pausing. Did you think of a pattern or did you see the pattern? If you saw that each time I have 9 in the ones, you are correct. So 8 plus 1 is 9. Keep that 30, so my answer is going to be 39. Right? So 40 and 7, I can kind of think of 47 as 40 plus 7. I say, hey, I'm going to add the ones. That give me 9 plus the 40, it'd be 49. Here, 6 and 3 is 9 again, so I know my answer is 59. 5 and 4 is 9, so 69 is going to be my answer. So as long as that pattern continues, I can use it to help me solve the problems. Okay, here we go. 8 and 1 is still 9, now it's 39. And if you look, this problem here is very similar to our first problem. So we're using this pattern, we're using the structure and the numbers to help us solve these questions. Okay, do you see any patterns here? Let's look at this one. We'll call this problem number 1. Do you see any patterns in this problem? If you do, shout it out now. What's the pattern you see? That's right. You probably noticed that I have one more nickel each time. So here I had 2, now I have 3. So I start with 1 nickel, 2 nickels, 3 nickels. If I continue, then I would get 4 nickels. But if I look at the numbers of the value, it'd be 5, 10, 15. So I'm not only getting one more nickel each time, I'm going up by 5, which makes sense, right? Because a nickel is worth 5 cents. What about here in problem 2? Do you see a pattern? I'm going to give you a moment to think about that. Do you see a pattern here? Well, at first you might say, no, Mrs. Del Rosario, I don't. I'm not going up by a nickel each time. Like here I have a nickel, and I have a dime, now I have a dime, and I have 5 pennies. And I say, you know what? You're right. There's not necessarily a pattern with the coins. In problem 1, I was adding a nickel each time. Here the coins are different. But can we find a pattern with the value of the coins? Let's check it out. So a nickel is worth 5, a dime is worth 10, and I know that pennies are worth 1, dimes are worth 10, so I have 10, 11, 12, 13, 14, 15, and my total value here would be 15. Now, if I'm looking at the value of the coins, I notice I have 5, 10, 15. Oh, I see a pattern. I'm counting by 5 still. So even though I'm showing the pattern in different ways in numbers 1 and 2, they are both still skip counting and going up by 5. So